Good afternoon, everybody. How you doing? Been all right, show? I've been missed here a couple years, but I've spoken here before. Has anyone seen me speak before? So if you came hoping for a whole bunch of Star Wars references, I've got some bad news for you. I flipped it more to Star Trek this year. I loved all 3 Star Wars movies, but I'm kind of done with them now. Anyway, without further ado, I apologize up front for the kind of trolly title that I put out there, but I'm actually not kidding. However, I should qualify. If anybody knows me from my past, they know that I've been all over the place with a little company called Checkpoint. Did a lot of security pieces. I don't regret any of it. It was fantastic. So it may seem, particularly if you know my history, a little odd for me to say something like, "Whoa, what are we using the firewall for?" But at any rate, the ability and the capability of the firewalls are something that I kind of want to focus into as a new architecture. Now, as part of my last role at Checkpoint, I was focused heavily on cloud and cloud architecture, and I had quite a bit of experience in that area, working and playing with a lot of our technology, such to the point where I actually even introduced automation pieces for our own technology. This allowed us to deploy in the cloud tools that would auto-deploy, auto-create. We could do test, massive amounts of throughput across infrastructure. I became actually a huge fan of the cloud and infrastructure as code and the ability to launch my firewalls as code quite extensively. We were able to do testing, pushing through. We stored everything in a private JIT, and then we could push stuff out for customers that would automate and control. Now, I'm going to see if... oh, good, the animations are running. It didn't run on the last one. So as a consequence of that, this is as close as, by the way, you get to a GUI in the cloud. When things are automated, you're not really much to look at. But what this allowed us to do, though, was scale and deploy security devices and infrastructure at massive rates and at massive sizes to qualify how many things were out there. Right? A customer would say, "Hey, I'm new to test, and my infrastructure is about the size of 20,000 objects." No problem. And I'd spin the whole thing up, demo it, including pushing tons of traffic through it, which people loved and people liked, and it was obviously very helpful in terms of them understanding, what their infrastructure looks like or what it would look like when we're deploying. The other thing I loved about the cloud technology was I could also write my own test clients that simulated what the site would experience, and boom, have that hammer the site such that those are real throughputs spread across geographically, spread across the world. From an infrastructure as code perspective, this is actually all just based on a single template that's spread across, and in my case, AWS. By the way, I should qualify too. I'm going to probably talk a lot about AWS because it's where most of my experience, most of my customers have been. It's not to say I haven't done a fair bit with Azure as well. I just want to qualify, and this applies to the firewall piece too. When I talk about specifically AWS or an Azure, it's not an endorsement of they're the best. I'm going to be very blunt. AWS, Azure, Google Cloud, Rackspace, which actually now just became AWS, they're all the same to me. There is no difference, and I don't think it's worth debating. There might be a minor feature in one that's awesome that will be superseded by the next cloud provider in about a week. Just hang in there. It's really not worth the effort. Likewise, on the firewall side, I'm going to pick on Checkpoint a lot, with apologies to Checkpoint, because I know them the best. But what I'm describing applies to the other vendors as well. So we'll just pick on the ones that aren't in the room. What do you guys think? Leave the Fortinet guys alone? They're nice, right? But anyway, here's my infrastructure spread across. I could spin up as many of these as I want, scale across. Really, it's from an architecture perspective, it's a very, very simple stack, right? I put, I've got my VPC, the internet gateway, I've got my virtual firewall in the cloud, and I've got just a simple little web service on the back to just demonstrate the capability of connecting through, protecting, et cetera. But there's a slight problem with this when I demonstrated for the customers. As cool as that was, and it got us our proof of concept piece, it's not really what the customer's environments look like. They're probably a little bit more like this, where they're going to have a whole farm of servers and services doing a whole bunch of stuff, and they're probably going to want to throw a load balancer on the top of that, the front, spin it across. All perfectly acceptable. But then I ran into one of my first problems when I was trying to work through this stuff with customers. And that first problem, of course, was that front-end firewall device suddenly became the bottleneck for everything. Because even though the elastic load balancers were unlimited in bandwidth across, as soon as I hit the front end instance, it would only get rate shaped exactly mathematically to the capabilities and throughput of that device, no matter what I had behind it. So, for example, if I had 5 small instances behind, I had to have a firewall that was 5 times the size of those in order to map through the exact data. And all of a sudden I found myself in this situation where I was trying to explain to the customer, well, the infrastructure to protect it was costing 5 times as much as the actual infrastructure. It was a little awkward. We're not used to that piece. But no problem, right? We can fix that. We can actually introduce more load balancing, right? Rather than bigger instances, we'll just put in more load. Or what I like to refer to as the load balancing sandwich. Introducing, so now I can load balance through the front end and then load balance it off the back end, still making sure I've scaled that thing up high because the firewall passing the traffic through could be complex, but it works well. Inevitably though, somebody at the customer side as we're building this out would say, well, this is all good and stuff, but it's not quite like what we're used to. We're actually worried about availability, so what are you gonna do about, HA? How can I have my high availability? Forgetting, of course, that the cloud by its very native is HA, which leads to one of my most hated designs, and that's HA in the cloud, where you decide, okay, I'm going to stick another firewall in place. In theory, that sounds like a great idea, because that's what you do at your data centers, right? In the cloud, not so much. All of a sudden, I've got a whole new level of complexity, and here's the problem. We continue to fight. By the way, these are real deployment guidelines from Checkpoint themselves, so I'm actually using their own stuff. The real problem here is there is no router. There's no switch. Do you guys know how failover works in network-based systems, right? They're harping out multicast addresses. They grab the traffic of the event. Well, none of that stuff actually exists in the cloud. Do you know how the failover has to happen? Anyone? Call it out. It's not a change of routing. It's an API call. Your machines have to have, the privilege to change the path of a track flow because it is a software-defined network. It's not a real network. There's no real router to react. They have to send an API call out on detection of failure to send traffic to the other one. If your customer is a heavy usage of APIs within the infrastructure, like, for example, auto-deploy, expect up to a minute delay for that to go through. Considering how we become used to not even losing a packet in our physical networks in our data center, the idea that this could take up to a minute is actually kind of frightening. In reality, the capabilities and throughput, et cetera, the failover, will actually cause you more problems than it will fix. Versus that first design I showed you with a single firewall, treat it like a single stack. And then if there's any kind of problem across anything on that stack, boom, move right over to the next one. The other issue I found with, quote, failover firewalls they're generally running in the same region, the same area, and probably in the same memory in the same machine. Because again, let's remember, there isn't really a switch and a router and a firewall there. It's all running in RAM. If there's a problem in that region, it's probably going to wipe out everything on there. Hence, you're going to see them say, hey, moving around to different zones, different availability regions. If you're going to do that, don't waste your time putting HA in each location. You'll actually just create more complexity and more failures than you'll ever fix. Although it seems natural to do, again, part of the challenge. There's one other piece in the back too, which I've got to describe, is that within the VPC component, and I should qualify in the Azure world it's slightly different, they have a different routing engine that you can code to, but in their SDN, even though you break up your VPC, your virtual private cloud, into different subnets, and you attach the firewall to them, and you can set all the routing you want. According to the SDN, if a packet comes out of the virtual interface here and needs to talk over here, the SDN, irregardless of what routing you put in there, will simply switch it across. There's no way it's going to actually waste its time sending it through an actual route and a path, et cetera. Boom, it cuts right through. Now, again, there's some trickery you can use to force it, but we start to bring into some, what I described, a more needlessly complex design. And there's actually another way we can get through with that, and that is something called transit VPCs. I really hate these too. The transit VPCs become kind of these focal points where you can build up services upon services and mesh them through other spokes, where this starts to look and act like your traditional data center. But there's a problem going on. There's something that'll start to happen. It's going to start to hit you, especially as you start to programmatically grow this thing out. Because your dev teams and your businesses go, oh, I want this, I want this. This, what I would describe as needlessly complex, although it's very, very reasonable in what you're looking at. And I should qualify something very important to say. Although I'm bitching and complaining about this, to be blunt, it works. It works just fine. And that's part of the challenge with the cloud. You can actually do things so many ways, it's mind-boggling. What's the right way for your business? So I will qualify that as much as I say, what do you need a firewall for? There are times and reasons you will need a firewall. If you're doing a straight lift and shift and you've got a same old traditional architecture and you're expecting the exact same results as your existing data center, oh yeah, you better put a firewall in the cloud. But then you're going to run into this other piece I have, and I'll describe this as the floppy problem. Does anybody remember installing Windows Office 95? Anybody remember that? Yeah, a couple of you out there, old enough. For those of you not old enough to remember, we had these things called floppy drives. And they held, 1.4 meg worth of data. And if you had to install some software, we'd spread it across a few of them. Well, at some point, Office would come to us in a stack of, 30, 50, 100, I don't know. Hey, one of my first jobs was just sitting there slamming disk after disk in all day while we loaded Office onto these systems. And here's the thing. That seemed perfectly normal, right? We did it for a long time before we went, what the hell are we doing? Why am I spending all day pumping floppy after floppy? It's the floppy problem. We do it in technology all the time. Something works so well for us for so long, we continue to use it long past where it actually makes sense, but it feels like it makes sense. It's comfortable. I knew what the floppies were. I knew how they worked. I knew how to make copies of them. Eventually, we figured out better ways, better approaches. And of course, likewise in the cloud, you're going to hit the situation where you recreate that data center, where you have everything running just like you did back in your hosted data center. It's going to be a lot of work and a lot of pain, but you're going to get it there. But then inevitably, somebody's going to come along and kind of hit you with something. Hey, we've got new technologies. We got new things to try. We got new stuff to do. I know everybody's seen this. It's been going around. You wouldn't believe the number of people who sent this to me after the whining and bitching I do in front of customers. But the part of it, the challenge is when we look at the cloud and we have the expectation we're just going to move stuff to the data center, we're going to lift and shift. Here's the first thing people forget. A lot of the data centers I work with, particularly the bigger customers, they have had this data center for 10, 20, 30 years. And it's been running like rock. It's solid now. But what they forgot was when we first deployed it, and I was involved in these few deployments, it wasn't so stable. It actually wasn't so good. The first couple rollouts were kind of painful, but we learned, and we fixed, and we adapted, and we made it better. And then 20 years later, we all forgot all the little tweaking and work we had to do. Now, when we move it to the cloud, our expectation is it should just run the exact same, and it's going to be awesome, just like it is in our home data center. But it's a brand new environment. You're going to find new quirks and new weirdness and new bugs. You're going to go through those growing pains all over again, and the business is going to hate you for it. But it's an inevitable piece if you want to actually take on new technologies and new pieces. So speaking of, I started running into these containers a lot, right? I was busy protecting EC2 instances, and I thought, well, that's, hey, I'm protecting stuff in the cloud. They kept bringing up containers. And now, have you ever asked a container person, a person using a DevOps team who's using container delivery, have you ever asked them to submit a change request with their IP address and port? Do you know how well that works? I guarantee you they have no idea what IP they're using or what port, and nor will they ever. To a security admin, it was kind of mind-boggling. How could you not know this? You need to tell it to me. Not only that, they call me back and go, well, no, it's changed again. Oh, and it's only going to run for 4 minutes. What are you talking about? So I had to do some experimenting, which led me into playing with my own Docker coding, started turning even our own applications into container-based. I don't know if anyone here using any containers in their environment, public or private. They're pretty slick. There's one. What do you think of container networks? They're fun. Now, they can be complex, but here's the thing. If you look at how container networks work, particularly a programmatic spin of them, this is the dream we've been having about this whole zero trust that we've been talking about. I can create these container networks. I don't call them micro-segmentation. I call them atomic segmentation because I can put every app in its own little universe and it has no idea what's around it, what's out there. However, I still wasn't quite sure what all that meant relative to security, because it's still just a server, right? It's still just a Linux server with a lot of VMs, is what I tried to dismiss it as. But of course, I took my team, and we did the software development approach. You guys have this model, right? That's generally how we design and build our stuff. I'm sure you guys do the same. I just openly admit it. We actually went out, did our deployments, testing, etc. And we started to discover something interesting about these containers, something that really caught our attention. And that was the ability for these things to be pre-programmed, set up to run very simple services. This is me launching a container host. And when the container host spins up, you notice it's generating the RSA private key stuff. You know what it's doing right now? It's actually spinning up its own microservice certificate authority. It's got a root authority and a signing authority. It generates a bunch of certificates, signs them, and pushes them out inside the other containers as they come up. It then destroys itself so that I have no record of its existence. I don't know where the root keys are. You can hold a gun to my head, and I can't tell you what's there, what's signed, whatever. It's all meant to run inside. Because once automated, it just simply starts up and runs. Now, to manage this system, I actually only have two options. I can deploy it, and I can turn it off. But I can't actually log into it as an administrator and make changes to how it runs. If I want to make changes to how it runs, I have to go back to the original deployment script, change that, change the application, how it works, usually test in a dev environment, not prod. And when I get to where I like, I launch it again. And if I don't like how that works, I go back to the original code and I deploy it. And we started taking this approach, and we realized some interesting things were coming out of it. And part of it was we wanted to test security. And so we came up with this thing called, we lovingly called it the jukebox from hell. The graphics on it are not nearly as nasty looking as they are now. That is a real website. If you're Canadian, you probably recognize what a C51.WTF is. Yes, I'm still pissed about that bill. But the jukebox was designed to take unfettered, unchecked input from the internet. Not only that, it's an open source code on the back that's actually using callouts to Lambda functions into like Google APIs, etc. If you give it some parameters, some words, etc., it tries to find music that we would associate with what you're running. And we put it up there because we wanted to test what's the risks and how do we protect against them. Right? How do I use firewalls against the cloud? I wanted to have essentially something we could take target practice on. And you're welcome to go take target practice on this. In the course of our testing, we discovered something really interesting. Again, remember that part about nobody can log in. Well, we set up this container such that if the running binary changed at all, crashed, whatever, the whole system would restart itself. We had a no reboot, no restart policy inside there. The whole thing would just blow itself up and come right back up. Right away, we started to notice some interesting things. Now, my code in the GitHub, it sends, actually, kudos to Microsoft and what they've done with GitHub. I was really terrified when I heard Microsoft bought GitHub. I thought, well, that's the end of GitHub. They've really done a nice job with it. They're actually nice enough now to send me weekly emails to let me know that my code base for this is highly exploitable and I should really fix it. Of course, in my case, I'm like, well, it has to be exploitable, otherwise it's useless. I can't test much if it's actually solid. So this is completely and 100% exploitable. The challenge is, how are you going to get persistence? Assuming you could get into this system, because it has no runtime, it has no shell, it has no tools built in there, it's not your standard Unix system, it only runs one thing. And the moment it stops running that one thing, it commits suicide, disappears as if it never existed, and launches again from its original image. Without that persistence, there isn't really that much that was happening. We could attack and attack this thing over and over again, and nothing would happen. And then all of a sudden, my security costs just came the cost of the infrastructure usage that was not servicing connections versus someone that was being serviced. By the way, while that machine was being hammered and dropping and restarting itself and dying, right next door to it, somebody who's legitimately using it is looking at their instance and running it and playing it. My mom actually turned out, I went to take this down. The reason it's still up is because of my mom. I actually went to take this down, and my mom contacted me and said, oh my God, what happened to that thing I put on her iPad for her? And what I realized is my mom remembers these songs from when she was a kid. She doesn't know the names of them, but she'll remember a line or a lyric. She can go here and punch in that line or the lyric, and generally speaking, it's been pretty good about finding the song for her. So I've actually left it up for my mom. But you are all welcome to hack it because she won't even notice if you're playing with it and breaking with it. It's been a few years now, so we're not, having it. And it definitely gets hammered from the internet. There's just a look at all the stuff that was coming in from the internet. But we wanted to take it up a notch. I said, okay, well, that's okay, outside threats I'm actually now not as worried about. Again, I have no IPS signatures. I don't have any kind of firewall on it. But I don't really care, right? This is my new security policy. Somebody may be attacking me right now. I just don't give a shit. It has no effect to me. However, I thought, what about insider threats, all right? Insider threats, terrible thing. So I spun myself up another container. Remember, I can't have administrative privileges, but what if I had another container next to it that was exploitable? So to jumpstart to that, I actually created myself a container with a shell I could log right into. And lo and behold, I discovered that with even the container host system, I had a hell of a time exploiting anything. And you got to remember, I was the administrator because I had no idea what that key was, and I never would. I was severely limited at seeing anything of the traffic, even if I figured out how to attach to it through the container network. There was really no routing between it if I'd segmented. The point being is that configuration, when done right, suddenly became the definition of my security without the requirement of enforcement, without the requirement of a device. And here's a point I really want to hammer in. Does everybody remember the first time they deployed a firewall on the internet? How long ago was that? 90s? I was in the 90s for me. So you have to remember at the time we deployed, I was working for a bunch of ISPs. When we first got our first web servers and email servers and everything online, right? We finally got it working. If you had told me then I would be busily putting in devices that blocked access to those, I would have told you you're out of your goddamn mind. We just got the thing working. Don't touch it. Don't even look at it. We got it working. Everything's fine. But then what happened? They started getting attacked. We hadn't really considered that. We forget this part. We hadn't considered the risk of what we've exposed. So what did we do? We made a decision that this wire going to the internet was a choke point where everything was coming in and everything was going out and represented our biggest risk. We essentially cut into it with, quote, a firewall, a tool. By the way, when I say firewall, next-gen firewall, super-gen firewall, super secret Hoover, whatever they call it now. You know what I mean, security gateway. We put that in there. And we figured out that is the best place to enforce policy because we can capture everything there. I didn't necessarily know what servers are even there or what operating systems are. I couldn't account for all of them. But putting something there allowed me to create a cohesive policy. It made sense, and it worked. And we've continued to do it to the point where today I think it's just on automatic. We've got a connection. Now, here's the problem. We start talking about SDN and container networks and all this kind of stuff. When we put in the firewall, are we doing it just because that's what we did last time, or are we really thinking this through? Because here's my issue. A software-defined network, by its very definition, is a reprogrammable path. Does that still sound like the best place to enforce security policy? Right? Or are we just repeating it because that's what we did last time? And of course, if you look at some of the traditional security vendors, I actually found this from one vendor's documentation, a lot of them have this kind of, attitude about the cloud where it's just inherently insecure. Just inherently insecure. Now, I don't know about you guys, but I've been in a lot of customer data centers that I would describe as inherently insecure. It's a reality of all networks. They're not inherently this or that. They're what you do with it. They're how you use it. And if we're not taking full advantage of the tools that are available to you there, you might be missing things. Now, I am worried that I was going to be the Grand Moff Tarkin guy going, yeah, okay, so there was one Star Wars reference. I was the Grand Moff Tarkin guy going, oh, there's no risk. There's no problems. Don't even worry about it. And assuming at some point this thing will blow up. So let me say up front, I'm not here to pretend I have all the answers. I'm here to say that we all need to start asking more questions. Because the first time we had our security breaches and problems, way back in the 90s, and people had them before that, if you read Clifford Stoll's the Cuckoo's Nest, the Cuckoo's Egg. This is an ongoing problem. It has been for a while. I think it's dangerous for me to assume I've got it all figured out. I think it's dangerous for all of us to assume that we got this figured out. You know how we got through the 90s? We worked with each other. We talked about it. We came up with different ideas. We tried things. The cloud is no different. I don't want to come present this all to you as if it's the mecca and the solution for everything. But I do have some ideas. And here's one that came up. This is from an audit of a customer's, this is an AWS environment. And we're looking at the access ports in. Now you notice port 22 from all over the internet. Why would this VPC system that contains customers, very sensitive data and servers, why would that have port 22 open? Anyone know? What are we doing with port 22? Come on, you guys know. Say it out loud. It's okay, come on, interactive, wake you up. That way I know you're here. It's SSH. They need to SSH to the system. They also have port 500 open, a UDP. Anyone know what that is? Yeah, they VPN in and they're going to actually access the whole system. There's all this remote access into the system. Now, at that point, I have to, and by the way, the SSH, I know you're thinking, well, you should only allow it from certain sources. Okay, SSH is only allowed from certain sources, etc. I guess my only risk is potentially what could be on the user's system when they're connected to my very sensitive data. But of course, we never worry about the users, right? They're perfectly safe. They're not a problem. As a matter of fact, I have never met a security marketing company that is willing to back down from a threat. So let's just take users off, because we have cool things like negative day defenses, right? People are actually traveling back through time, figuring out exploits and bring out. Can you imagine developing time travel to solve security? That is commitment. I got to give them credit for that. I'm being facetious, of course. I don't really trust the users. And so I started to make suggestions like, hey, we should probably A, take out the firewalls, B, do some focus on this config, and C, no more administrators ever allowed to log into our systems. Cut that stuff right out. And I spent this around along, with my resume and stuff. Some people, actually I'd forgotten back in the day, in the 90s, I started hacking a lot of stuff too. Not a lot of people were receptive to this. As a matter of fact, they were terrified when they were getting emails from me that said, oh, turn off your firewall, do this. They didn't actually accept that that it was me. They figured I was something attacking them, or potentially me attacking them. But I started to notice in the market, there's really 3 kinds of customers out there, right? It's not broke. I'm just gonna lift and shift that in there, and I'm gonna leave it as is. That's great. Or, you know what? I'm just gonna leave it in my data center, which is fine. It's a perfectly reasonable strategy. Now, there's also the innovation people who were like, whew, we want all new. I want everything new. And if you look at the Netflixes and Ubers and the people who have really adopted cloud like that, it wasn't really a risk for them because they didn't have anything before that. What's the risk? They could only benefit from doing literally anything. So I don't think it's fair to lump them in as they took all the risk and did well. They had no risk. They had nothing to lose. But most people fall into that middle where, I hear it all the time, we're going to lift and shift into, because I'll tell them we can't do this. It's just like your data center. We've got to make changes. We've got to look at migration. They see that as a risk, and their immediate message is, no, we're going to migrate it to the cloud. Don't put up your hand if this sounds like your organization, but I bet it does. We're going to migrate it to the cloud, we're going to lift and shift straight into the cloud, and then we're going to migrate it to cloud services. I've been through a lot of deployments. I have yet to see that really happen. Actually, after enough time, it starts to. Because you know what stops it dead in its tracks? Remember that part I mentioned about, hey, our data center is running great, everything's perfect, and we're just going to lift and shift it in the cloud? You're going to have a lot of problems. A lot of stuff's going to break. You're going to encounter things you've never seen before, and the business is going to lose their mind because they've been used to that wonderful, solid data center from before. And they're eventually going to lose patience, and when you get things stable, they're going to go, stop! Nobody touch anything. And your chances of migrating to cloud are going to go poof, up in smoke. So just a caution when you hear that term, oh, we're going to lift and shift and then we'll migrate to the cloud. I don't really believe you will. I think there'll be too much pain. Part of this too is prepping the customers for the pain that they're about to experience moving to the cloud. There's this delusion that, oh, it's in the cloud. It's perfect, it's easy, it's quick. It's, everybody talks about, rapid recovery, rapid deployment. But nobody ever talks about rapid destruction. You ever automated a mistake? Try it sometime. It's a learning experience. It'll wake you up faster than any coffee. Luckily, you can unautomate a lot of your mistakes, hopefully. But when you look into the thing, a lot of people were complaining to me that they were going to lose visibility. And I'm like, well, visibility of what? This is just my dev team's testing VPC where they can spin up their own zones, et cetera. Correction. You know, as I look at it, it's been growing and growing, and sometimes they leave remnants around. Eventually, I'm like, Jesus, what am I really looking at? What is this thing supposed to be? And not only that, these guys are programmatically now creating objects and rules. Now, you remember your firewall policy? We'll pick on the firewall policy. It started off, it's manual, right? A human has to go in and approve it. But somehow, you've ended up with 500 rules, 1,000 rules, 12,000 rules spread across. It's pretty big, isn't it? Is it scary? Well, folks, wait till you get to automation of your networks in your design. Yes, that little Tron-looking diagram in the back there was just one attempted index of one customer's security environment, VPCs, etc. Because you can programmatically launch this stuff, it is going to blow up like you've never seen. You think it was bad before when you had approved process and somehow still ended up with 1,000 rules? Wait till you automate it. Wait till you see what comes back there. You could just imagine. Actually, we don't have to imagine. I know what it's going to look like. And this is the crazy part. We all act like we're that guy. Oh, yeah, look at that. We see what's going on. Oh, yeah, I got to have logs. Where's the logs? Right? Where I'm left asking the question, what the hell are you actually looking at? What are you really doing here? And of course, every vendor has the same answer when you say, oh my God, how do I solve this problem of visibility in the cloud, let alone my own data center? By the way, I would argue that you don't really have visibility in your data center right now. These are massive infrastructures already logged. Now imagine that 10 or 100 times more. Of course, the stock answer, artificial intelligence, machine learning, which is somehow artificial intelligence. I cannot describe to you how angry this makes me. By the way, machine learning has been around for 50 plus years. And if you go back to the original descriptions and designs, never once was artificial intelligence even mentioned. Isn't that weird? In the original design plan for machine learning algorithms, they never once talked about artificial intelligence. But for some reason, we do. And so here, I want to equate something for you. I'm going to tell you a little story. Learning and playing in the cloud, before I actually started working, I started to set up some stuff myself. I have a little media server that we use to watch TV shows. And I created these bots that go out and get TV shows for me. But I figured I was going to teach my bots how to use artificial intelligence to just get movies and stuff for me, because I'm so lazy I don't want to think about it. Now, it was built on that model where I never have to log into it. It's self-healing, looks after itself. I just blow it away and redeploy it if I have a problem. Never think about it anymore. But I thought, wouldn't it be cool if it actually curated? Now, there's a couple problems I had up front I'm going to explain. First off is I don't have nearly enough data with family and friends to actually pull this off. But I didn't let that stop me. I kept shoveling the data in. Every Friday I would get batch uploaded to a S3 bucket, because anyone with a credit card can access machine learning. It would get processed out, and I tried to write responses. And the first week I did it, absolutely nothing happened. So I started using glob expressions. You guys know what that is, right? So I started saying, well, just kind of match stuff, and ran it through, and absolutely nothing happened. And so I'm like, well, let's lower the confidence level of this, expand the glob expressions, boom, run it, and absolutely nothing happened. And so eventually I got bored and I moved on and I forgot all about it, but it kept running. And then we had in our house what I describe as the Marvel incident. And what that was my son decided, even though we have Netflix, he decided he wanted to watch on our private monitoring system. He wanted to watch a show called Luke Cage. And Luke Cage came out. Now, when it came down all at once. And the machine had never actually indexed logs where an entire show had come down, boom, all in one shot. And somebody, my son, sat and watched every episode. And because of my dumb glob expressions, the machine learning determined that anything with the word Marvel in it must be freaking awesome. And we're going to go get some. So as of Saturday, my wife's going, hey, I can't get to the media server. I'm like, how's that possible? It's in the cloud. I go and look, and it was on its 300th download of God knows what. By the way, did you know there's such a thing as Marvel porn? And not even a little bit. Now remember, I can't administrate this thing. But I could get into the buckets that it was storing through, and I went in and said, okay, well, first off, I'll clean that out, and I erased a whole bunch of stuff and deleted. You know what the damn thing did? Oh no, we missed it. Boom, re-queued it all. My web interface to monitor it started crashing galore, but the API in the back end that the instances were talking to ran like a champ. And it continued to plow through. I fought with it for quite a while because I wanted to try to recover it, and eventually I had to punt the whole thing, lose all the thing I was learning. But the point of that was really learning that what machine learning was, what it really meant, how it actually worked. It's really not magical. There's only 8 different algorithms that's actually applied against it, and how it's being used is very interesting. Because you buy a product with, quote, machine learning, or they just call it AI, there's no such thing. There's no such thing as artificial intelligence. Hell, there's barely real intelligence in some of the places I've been. But the idea that you're going to throw data at some kind of machine and it's going to do wonderful things is so wrong. This could not be more accurate. Machine learning is just a different way to program the machine. If it's programmed badly, it will act badly. Do not let the vendor tell you, oh no, machine learning, artificial intelligence. Those are not real things. Those are not answers. As a matter of fact, they annoy me more than ever now, which algorithm you're using. And what you're going to discover is you're going to buy a product that goes, oh, we use machine learning or artificial intelligence. Yes, they do. They use it to make their product better. But the idea that it has anything to do with the customer's data or going to help you understand your business better is laughable. You have to have your own instance of machines and things you're looking for, because there's a lot more we have to consider. And one area we actually are applying machine learning, makes sense, is the authentication. We gave up looking for the ultimate authentication. And by the way, when I say authentication, I don't mean just authentication of users. I mean authentication of all my systems. Everything that runs in our system now is authenticated some way or another. And there's lots of different ways to achieve those trusts. Like those private certificates I talked about, by trusting, outside PaaS, SaaS with some kind of maybe certificate or two-factor. We've got biological identities. There's a lot of pieces there, but essentially taking all these authentication methods, incorporating them, and then learning based on the data we're programming. Again, I hate the learning term because everybody thinks it means something different. To build trust confidence. And based on the trust confidence, I can apply that to access to certain systems, including whether these systems can talk to other systems. So I'm not saying that it's not a very applicable or useful system. Machine learning definitely has huge, huge values in our infrastructure, so don't completely dismiss it, but we have to be a little bit more realistic about it as we're in that trough of disillusionment. We're like, this stuff's crap. Anyway. So question, how do you get involved in this? How do you actually make the most of these things? So I've got some bad news for you if you're a traditional firewall person that really just wanted to buy a product, turn it on, and go, there, we're safe. It's not going to really work like that. You're going to have to learn or work with some programming. Now, it's not as bad as it used to be, but you're going to have to figure out, I put it more akin to glorified HTML these days. A lot of modules are already built, and when you're talking about infrastructure as code, you're not writing anything from scratch. 500 people have written whatever you're trying to do 100 times better than you have. Now, you will run into some challenges. For any programmers out there, does anybody see an issue with this return value? You must know what that means. Yeah. So I get a 200 response code, which in the REST API world means success. Except my status came back as failed. The API is telling me, yes, we successfully failed. You're going to have to deal with stuff like that. There's going to be quirks. Nothing's perfect. But you're not going to find these things at the top level with the tool. You're going to find it at the low level. You're going to find it programming. You're going to find it through your systems, through your key values, which suddenly now represent your infrastructure as ephemeral devices that can restart and relaunch. Now, as part of this too, you have to be careful about your supply chain. And by that I mean, as you can see here, I actually got a little defensive because my team caught me copying and pasting code from China, which they didn't think was a good idea, but I was like, screw you. Well, actually I was a little more vocal than that, as you can see. But this does lead to the question, though, when I look at, as much as I lock down this infrastructure and the infrastructure is code and I build the security and the infrastructure is code, there's still that entry point of something getting baked in at a very early level. And you need to be really careful where people are plugging stuff in. Because if somebody's managing to hook into your microservices, I actually envision a whole new way in terms of where people could hurt us. So you imagine a monolithic system out there, and suddenly somebody starts leveraging the concepts and services of microservices. What would the attacks of the future look like for us? What would it look like for a monolith versus a microservice? I thought this was a pretty good representation of what we may be facing in the future. And by the way, it doesn't turn out too well for the monolithic system. I'll leave it at that. You've probably seen it before. So just a couple of points. Moving to the cloud, thinking about security in the cloud. Don't just jump to what firewall we got there. Start talking about your business functions, not the products. Your software supply chain for this is going to be incredibly, incredibly important. And we're talking about least privilege with the least code. And everything must be programmatically deployed. When done that way, you can get what I call the zero to hero. And truthfully, I just stole this from Netflix, right? You guys know about the Netflix Chaos Monkey and the Chaos Gorilla? You guys know about the Chaos Gorilla? They wipe out an entire region. But essentially, what I've done with customers is we come in and go, okay, whatever you've built in the cloud, oh, okay, this is what you're running. By the way, in dev. I scared somebody one day when they thought I meant to do this in production. So you build something in dev. We go over to the dev system, and I go, poof, and I delete the entire thing, and we say, go. How long does it take you to bring this back from nothing? And if they panic and freak out and run around and scream and cry, you're not ready to put stuff in the cloud. You're not even close. You need to get a zero to hero. That says, I can turn it on like a switch, I could turn it off. Now, when you get to that point, you could do what I call next is the no reboot, no restart policy. No system will ever restart in the cloud. It will be destroyed and redeployed. And when you get to that point, you can actually get to the point where you go, listen, administrators, I know you love it logging into production because you're the cool, hot, administrator on port 22. No more. No one is allowed in. Because it's amazing how many problems and things we solve based on just doing that. And having said that, you're going to have to consider how we're going to deal this, right? Utility is a service, not a server. It's not about the server itself. Because the benefits are massive. How much free space do I have on this system? This is just one of my containers in the cloud. How much free space does it have? Anyone? I got 8 exabytes of free space. Do you know what's costing me right now? About 20 bucks. Because I actually only ever pay for what I use. Imagine never having to think about hard drive space. Oh, and I just recently moved a bunch of our stuff to serverless. I'm going to have a whole new presentation on that. I'm a new fan of serverless. Now, I'm not saying everything needs to be serverless, but your little jobs you're doing, whew, what a difference. Not only did we go from costing us $300 to $500 a month to support a server to about 3 cents a run, massive difference in price, but the time of performance. Here's the thing. If your competitor figures out how to do these things that much quicker, more efficiently, and that safer, they will eat your lunch. They will change through. And so with that, I'm going to leave you with just one more thought in terms of how you deal with the cloud. It comes from a song of mine. But as you move forward with all this stuff, remember to keep yourself as agile and as focused as possible. And the ability to actually destroy and redeploy is probably one of the most advantageous pieces of all the cloud. And so with that, I hope you have a great time. I'm probably short on time.
And I'll tell you why. I've come a long way since I believe in anything. And I've come halfway around the world. What are you talking about? Where you come from is gone. Where you thought you were going to, we're never there. And where you are ain't no good unless you can get away from it. You understand?
Yeah.
You understand?
Yeah. There's only one thing left for me to do, mama. I gotta ding a ding dang, my dang a long ling long.
Thanks, everybody. Yeah, I just had to jump in there. Any questions or comments? I know I'm getting very low on time here, so we probably won't have time for questions. But if there's any, I'll be hanging around. Again, this is something we should be talking about. I'm not trying to enforce this as this is the word. I'm saying we need to think about some new ideas and some new approaches with what really is a new technology. Thank you.